guess let's go to the next speaker. Brendan, take it away, introduce yourself.
Sounds great. Good evening, everyone, or wherever else you might be. And by the way, first and foremost, Deepthi, wonderful presentation. That was fantastic. Steve, thank you so much for having me for the LA Data Platform Group. I really appreciate the opportunity. My name is Brandon Tucker. I am I like to say, a data geek. And I've put this presentation together. This is probably about 1.5 years old at this point. But I wanted to put this together because I had some requirements in terms of really diving deep into Query Store. And when I started talking about it with people, I realized that there was a lot of, I think a lot of expectations and then a lot of confusion as to what it really does. And so I wanted to put together a 1 to 200 level course or talk that would really be able to describe what Query Store is at a really high level, make it very approachable, because it can be a little bit scary at first and seem like a little bit of witchcraft and voodoo behind the scenes, but it's really not that bad. And I think with today's talk, maybe that can start to get dispelled a little bit. And maybe you can find a couple nuggets in here that would be good to be able to use in your day-to-day. So my nice little bio slide. I've done way too many roles for my own good. I mean, I've been a production database administrator. I've been a data engineer, solutions architect, database developer. Really covered the full gambit of data professionalism, if you will. All of it, for the most part, has been relegated to SQL Server. I did have a little bit of a hiatus in doing some open source data engineering, so that was a fun opportunity. But I really enjoy solving complex problems and then taking what I learn and then packaging it up and putting it into PowerPoint and then broadcasting it back out wherever I can. And that's what really gets me going. I've been active in the Denver SQL Server community for a long time. I first started probably about 15 years ago, was on the board for a little bit, and then have spoken at PASS and various user groups, code camps, SQL Saturdays, et cetera, et cetera. Right now, I'm currently actually on a break. First time in my career. It's actually really nice. I don't have an alarm clock waking me up. I actually get stuff done at the house. So this is really fantastic, but I'm currently on sabbatical through July, so I don't have a current company that I'm working for. My LinkedIn information is right there at the bottom. So please feel free to reach out to me, connect with me, network with me. If you have follow-up questions, please feel free to reach out on LinkedIn and send them over my way. Ground rules for today's talk. And I typically will tell this a little bit more when I'm in person and giving a presentation, but I like to have conversations rather than presentations. If you have questions, please ask them, and ask them when they are happening. I would much rather have the question be answered in a contextual manner. So when it's relevant, let's get it answered right then and there, and I'll be relying on Steve to help me out with that. So if you have a question, if something I was trying to explain didn't quite make sense, I mean, please feel free to drop something in the chat and Steve will slap me around a little bit and maybe jump in and just kind of keep me honest about answering those questions. So please ask them. I'll also leave some time at the end of each section as well as at the end of the presentation for any questions that we might have. So without further ado, let's go ahead and jump in. So today's session is just an introduction to Query Store. So we have an agenda here that we're going to go through. We're going to start with what is Query Store. So we kind of need to define it and just understand what it is and what's going on. We'll go through what query execution means. It's kind of some important fundamentals that we need to understand in terms of diving into the rest of Query Store. We'll then go to talking the talk. So we'll learn some terms, be able to communicate with others around Query Store information. We'll talk about runtime and wait stats, which is kind of like the fundamentals of what Query Store is going to capture for us. For those that are a little bit more GUI centric, which I know I am, and I feel like I'm aging myself even saying GUI. I guess I should probably say UX nowadays, but we'll look at what Management Studio provides to us out of the box. And spoiler alert, you already saw some of it from Deepthi's presentation, so it's not going to be anything overly new. We'll talk a little bit about plan forcing. It's kind of a fun little thing, and it's kind of advancing up just a little bit past maybe what this is, but it demonstrates the power of what Query Store can do. The power of Query Store is definitely reflected in Deepthi's talk, and I mean, really diving in and going into query hints and the tuning recommendations and intelligent query processing and all the things that have been added over the years that essentially utilize Query Store data is incredible. So I would encourage you to, once done with this, dive in and really start embracing Query Store. It's some really cool technology that I think you'll get some good value out of. So I always typically start my presentations with a definition, and this is very canned. We pull it from Wikipedia, we pull it from books online or SQL Docs or whatever it's called these days. But what is Query Store? And this is how Microsoft defines Query Store. So the Query Store feature provides you with insight on query plan choice and performance for SQL Server. It automatically captures a history of queries, plans, and runtime statistics and retains these, fun part there, for your review. It separates data by time windows. We'll talk about that. So you can see database usage patterns and understand when query plan changes happen on the server. That's definitely a subset of the full definition, but I think that encompasses it pretty well. So what does that mean to us? What it means is that it's a treasure trove of information about how our queries are running. Everything that is happening under the covers that we normally don't see, it's captured in Query Store. And so we can start really diving into it and leveraging that data for our own benefit. So sounds great. How do I turn it on? Well, good news. It's enabled for all new databases in SQL Server 2022. And I really emphasize that new databases part. Deepthi touched on it as well. But if you have a database that you back up on 2017 and you restore it on 2022 and Query Store was not already enabled on it, it will not be enabled on it on your 2022 instance unless you actually enable it. So for new databases on SQL Server 2022, it is enabled by default. It's also enabled in Azure. So Azure is the newest, latest, greatest, all that. So we would expect then for new databases to have that, and you'll see it in Azure. One note, and this was as of creating this presentation, is that it's not in Synapse. I don't know if anything's changed on that, but as of creating this presentation, it was not enabled in Synapse. What is interesting, though, is that it has been around in SQL Server since 2016. So it's definitely evolved over the years. You can essentially just run a simple T-SQL statement that you see there on the slide to enable it. And you'll see that there's a little bit of optionality on the bottom statement there of operation mode read write. Yes, there is kind of like a read-only version as well, but this is how you enable Query Store for a database that doesn't already have it turned on. It's very straightforward and very easy to do. This will lead us into our first demo. So we have both the T-SQL option as well as a GUI-based option as well. So we'll go ahead and jump into our trusty Management Studio. Bear with me 1 second here. Slides are still showing up on my screen. And let's get us over to Management Studio. There we go. All right. So what we're going to do here, we're going to run through a sequence of scripts for our demos. Hopefully these aren't anything over the top too crazy on their syntax or what we're trying to accomplish. If you have any questions on what we're doing, please ask. Again, going back to that whole, I want to have a conversation with you rather than a presentation. So our first step here is we're going to jump on our instance, and we're literally just going to make sure that we have a fresh database. We're going to name it demo_QS, QS being Query Store. So we'll get those run, make sure that those are successful. And then what we're going to do is we're just going to create a table in that new database that we just created. We're going to populate it with kind of some dummy data. 2,000 to 2,500 rows worth of data. We're just going to pull from sys.all-objects. So it's not anything meaningful data-wise, but it just has something that we can work with. So 2,600 rows worth of data now in a single table called TBL1 in that new database that we just created. So let's take a look. And this is a 2022 instance, just to give you the lay of the land. We're going to run this query here against the sys.databases DMV and see what does our query store state look like. And right now we see that we have database ID 5. We have the name demo QS, and is query store on? Well, that bit says 1, so it is currently enabled. That's good to hear. So I did not lie to you, I promise, because I created this new database. It's a 2022 instance, and query store is already turned on. So we're good on that front. The next thing that I do want to talk about is this DMV for database query store options. So this is going to give us all of the options that are available to us in query store. So we'll see really quick here that we have this desired state, an actual state. So read write, read only. Going back to that little option that we described there in the PowerPoint slide, this is what allows us to actually capture new data in query store. We then have pretty much a plethora of other options: flush interval, interval length minutes, max storage size. We're going to talk about all these here momentarily, but I just kind of want to show that there are a good amount of options here inside of this DMV. So if you ever need to go get that information from a query perspective, this is the DMV that you'll be using. What we can also do is we can take a look at our database. So we have this new database here, demo QS. We're going to jump into the properties. You'll see that we have this little tab here in this new window that popped up called Query Store. Well, that's really convenient for what we're looking at here. We'll see essentially all of these same options that we saw in that DMV, just displayed in a slightly different manner. But what is interesting, though, is that we get some nice little pie charts here at the bottom. So we can see what the current disk usage is for the database itself, which is 16 megs. But what's interesting is that it calls out query store used. So why on earth would it be calling out query store used? Well, what's interesting is that all of this data that resides within query store is stored inside of the user database. I'll say that one more time. The query store data is stored within the user database. So it is not stored at the instance level. If you bounce your instance, if you do any other crazy things like clearing the procedure cache or anything like that, you are not going to clear the data that resides in query store. If you back up this database and restore it on another instance that is able to do query store, that data will go with it. So that is one really nice part about that data residing within the user database. Now, that is a double-edged sword in a context, because that means that you now have additional data that's going into your user database that may not be front and center. And so what this second pie chart is calling out is what query store space is available and what's currently being used. So currently we have it set to allow for 1 gig worth of query store data. That's the default. You can absolutely change that. I mean, you have this option here, this max size MB, and you can absolutely change that to something else if you so desire. So we can just scroll through these options. We'll see a variety of them, but just want to call out where that is inside of Management Studio if you're a little bit more GUI-centric rather than T-SQL-centric. What I am going to do here real quick, just for our demo purposes, I'm going to run this T-SQL statement here. And what this is going to accomplish is we're going to essentially run an alter database statement. We're going to set query store, so we're going to set some query store options. And what we're going to focus on here is this data flush interval seconds of 60. And we're going to set our interval length minutes to 1. So we're going to set essentially both of these options to 60 seconds. I'll explain a little bit more about what each of these mean, but this is just for demo purposes. This is to make sure that we get immediate feedback based on the demo that we're doing. Do not do this in practice. Don't do this in production. This means that essentially data is going to go in a very quick fashion, and it could potentially cause performance issues. So leave them at the default and then adjust them if needed. So we're going to go ahead and run this alter database statement. It was successful. And then we'll see real quick that through this same DMV that we were using earlier, that our flush interval seconds is now 60, our interval length minutes is now 1. So we've updated our query store options just for this particular database that we now have. So I'll do a quick stop there if there are any questions. Otherwise, we're going to move on to the next session on queries themselves. Great. So this is just going to be a quick primer on how queries run. I mean, this is an oversimplification of it, but for those that aren't necessarily as familiar with it, when we type out a query, select star from table, and then we press F5 or run or whatever it is that we do to actually fire off that query, we're going to submit that query to the instance. That the optimizer is going to check the plan cache, see, hey, have I already run this query before? And if I haven't, it's then going to compile or optimize that query, and then it will actually execute that query. If that query already had been run and it already existed in the plan cache, then it's just going to skip that middle step of compiling and optimizing that query. Again, oversimplification, but this is important for all the topics that we're going to talk about here coming up. So let's start talking the talk on query store. In the context of query store, a query is defined as any old query. This is going to be unique SQL text. And I really hone in on that because it's based on the actual text that is submitted. And so if you change the text just slightly, even though you don't change the meaning of the query, that will mean that that is a different query per query store. One thing that I do want to call out is that in the context of query store, a query is not an individual query execution. So if I take this little select star from dbo.tbl1 that I have listed on the right there, and I run that 5 times, that's just one query in the context of query store. We then also have a plan. A plan is an execution plan, very comparable to how we know a plan in our day-to-day. A single query can have multiple execution plans. So store that away in the back of your brain for the talk a little bit later on here. Plans that are stored by query store are estimated plans. And so most of the time, this really doesn't matter, but I just really want to call that out, that these are estimated plans that are getting stored, and that to get actual plans, you're going to need to go to more specific data. Technically, the estimated should always be the actual. It doesn't always happen in practice, but definitely a topic for another session that could probably go for 5 hours. So we have our query and we have our plan. Those are going to be the fundamentals of what we need for diving into this data. So I talked about 2 different intervals when we were going through the configuration options. The first one is called the flush interval. Query store holds all of its data in memory to start. So we know of Hekaton, we know of in-memory OLTP, whatever you want to call it. But when that data is piped in, it is going to get stored in memory. That data is then periodically flushed to the on-disk tables in the user database. By default, that is set to every 15 minutes or 900 seconds. I don't know why they decided to do seconds for one of the intervals and minutes for the other, but it is what it is. So that is the default. So every 15 minutes, that means that by default, if for whatever reason you have an event on your database where it just the power cord gets plugged, not that that really happens anymore, but let's say someone pulls the plug on the server, that you could lose up to 15 minutes worth of query store data because that's being held in memory, not on disk. So something to keep in mind. The second interval that is of interest is called the collection interval. And that's essentially going to be time periods that statistics, runtime statistics, and wait statistics will get summarized over. So essentially, if we say that query X ran for 5 times with an average duration of 2 seconds, it's going to be over that particular time interval or that collection interval that we're talking about here. By default, when you enable Query Store, that is going to be 60 minutes or 1 hour. So all this data is summarized over a 1 hour period. So now that we have all that, I do want to bring in a little bit more of a complex chart that is brought over from SQL Docs, Books Online, whatever we want to call it. So this expands a little bit on what we talked about already. And so as we come back here, essentially this part right here is what we already talked about. And then probably also this one over here. What is interesting, though, is that when we have Query Store turned on, we're now adding additional steps here that the optimizer can do. So it's going to essentially have a two-way conversation with Query Store to check to see if it has data in there, if it needs to be taking action because of it, if we have forced plans, which we'll talk about a little bit later. But it's also going to make sure that it writes its information, and then also at the very end, based on how things actually ran, is that it's going to send its statistics back to the Query Store as well. So we're going to have a lot of good data based on what gets run because of that. So we're building upon what we talked about in terms of the high level of how query runs. Adding Query Store adds an additional layer of complexity to this. So on to our second demo. This is where we start getting into a little bit more fun here. So we're going to cancel out again because it wants to hold on to my window for some reason. So first and foremost, we're going to run this statement here, very similar to what Deepthi ran a little bit earlier, but we're just going to clear Query Store for this database, make sure that we're working with an absolutely clean slate. We're going to use our database. And then we're going to take a peek at these 3 DMVs here. These 3 DMVs are going to be your friends for the rest of the presentation here. So we have sys.queryStorePlan, sys.queryStoreQuery, and sys.queryStoreQueryText. These are kind of the foundation of all of the data that's going to be inside of Query Store, minus the wait and runtime statistics. So we'll run this real quick. And it's going to be empty because we literally just cleared all the data on the previous T-SQL, so we expect it to be empty. But let's go ahead and start diving in. Let's start running some queries. So let's do a select star from that table that we created. Just a quick reminder, we created a table called TBL1. It has 2,600-ish rows inside of it, has an ID and a little bit of textual information in it. So here's that data here. And then let's go ahead and run another query. We're going to change it just a little bit. So we're going to select from that table where ID is greater than 10. So very simple queries, straightforward. Now let's take a look at those same DMVs that we pulled up earlier. Well, they're empty. What happened? I told you that queries get captured by Query Store, right? That's why we're here late on a evening learning about this kind of stuff. Well, here's the reason why. These queries that we ran here are considered trivial. They just don't do a whole lot. There's nothing really important about them. They're not special. And I mean, maybe their mothers told them that they were special, who knows? But we, in the context of Query Store, don't consider them to be special enough. So sorry for these queries. They can cry tonight, but unfortunately, they're not important enough to capture, so we're not going to capture them. We're not going to induce that extra overhead in order to capture that data. So if it's trivial and it's not important enough to capture, well, let's do something that's a little bit more meaningful. Not that we would do cross joins and do open-ended likes and just do really bad predicates, but we're going to run this query. It's going to take, it typically takes about 15-ish seconds. All right, perfect. 9 seconds today. We're cruising. So just a quick heads up on this query. We're doing a self cross join onto this table, and we're just filtering down on a couple of these columns to really make something meaningful inside of Query Store. So if I were giving this presentation in person, I would ask people, does this seem trivial? Does this seem not trivial? I'll let you guys raise your hand on your own in the comfort of your own homes, but spoiler alert, yes, it is meaningful. That's why it's in this presentation. So let's start walking through the data that we have here. This first DMV that we have, and this first column is the actual DMV, so it helps to kind of keep things on track a little bit. So we have the plan DMV. We see that a query plan was generated. We can actually grab the query plan XML right here if we so desire. And we have just a ton of data. We see that it is parallel. We see the initial compile start time, last compile start, last execution, how long it took to compile, all of those goodies here at the plan level. At the query level, we have our query hash, when it compiled, last execution time, similar types of things, as well as some additional information in terms of optimization and whatnot. So really cool stats to have. And then the query text itself. So if you ever need to figure out how a query ties back to the text itself, you'll join this DMV query to query text. And then this is where we see that actual query text that we ran in that particular query. So I'll pause there for a second, let that sink in, but we're starting to see these actual values start showing up in the query store DMVs. Now, what we can do here real quick is we can see that we have a last compile start time, a last execution time. We'll look at this last execution time at 3:26 UTC. We'll run this query. This is the exact same query that we ran above. We'll give it the 10-ish seconds to run. And then we're going to take a look at these DMVs one more time. And we'll see that last execution time, it's still showing as 3:26, but that's because of going back to our flush interval. So that data hasn't flushed to disk yet, so we got it too quick. Now we see that updated to 3:28, whereas it was 3:26 previously. So we adjusted those values down to try and make this demo much more meaningful. You might see a little bit of that lag, and we just showed that lag, even with me lowering it to the lowest possible setting value, which was 1 minute, that it still took a second for it to register in these tables. So what are we going to do next? We're going to run essentially the same query, but what we're going to do is we're going to change this predicate, this where clause, just slightly. So up here, we have it as a %s. We're going to change it to a %b. We'll give that a run. This will take, again, probably 5 to 10 seconds. So no, even faster. So it's happier with what we're doing. And let's run this. Again, this is typically where I have people do a show of hands of how many plans do we think are in there, how many queries, how many query texts, but we'll just dive ahead and here's what we now have. So we now have 2 plans, we have 2 queries, and we have 2 query text. And if we expand out this query text, we'll see real quick that we have a %s and a %b right here. So we see that the 2 different queries that we ran are now showing up in query store. So that's good. That's what we want. That's what we expect. So how do we start generating different data based on the same queries that we have without changing those queries? Well, one quick and easy way is let's go ahead and create a clustered index on that table that we created. Because we were a good DBA when we created that table, we did not create it with a clustered index. Somewhere, some people are groaning in the audience that we didn't create a clustered index. I know, I've been there before, it's okay. But we'll go ahead and create that clustered index. And then we're going to run the first query that we had with the %s one more time. It's not really going to run a whole lot faster just because of this crappy second predicate that we have on here. But 9-ish seconds later, we'll have it, which we do. And then we're going to run our trusty DMV query again. And we're going to see that we now have an additional row in the plan. So we now have 3 plans. We have 2 queries. So just reinforcing what we've talked about already, queries are unique SQL text. We did not change the SQL text. That is the exact same query that we ran the first time. So we did not change the text. Therefore, we do not expect another query to get generated because of it. Same thing on the query text DMV. We did not change the query text. There should not be another row, which there is not. But there is a new plan because we created a clustered index, and now that plan is going to be different. I am going to run this script here. This is going to run just a variety and different set of permutations of the queries that we've been working with, but essentially this is going to populate some query store data with us in the background while we continue forward on the presentation. This is a great time if we have any questions. Feel free to jump in if anyone has anything.
Just in case, are you going to be talking about a trace flag for the query store as well?
I do not have anything related to the trace flag for query store at the moment in this presentation.
Got it. Okay.
Is there something?
Come to think of it, there are questions. How much overhead does query store add to queries?
In terms of compute, not a whole lot. Really, it really depends on the configuration options. We're talking about low single-digit percents with the default settings.
Got it. So
there's so many factors that are
negligible.
involved. It is negligible with the default settings and with a normal query pattern database. Now, if you have tons of queries coming through, if you're high transactional volume, if you have recomputes on everything, I mean, that's going to change. But in general, that's kind of the guidance. The big thing, though, is going to be the disk space that gets used for that. So definitely keep that in mind. Some people get like just blown away by it where they have this 500 meg database, but by default, it allows Query Store to take up a gig worth of data. Not that we really work in those terms these days, but 10 years ago or 15 years ago we did. And they see, well, hey, my database has doubled in size. What's going on here? It's, well, because you turned on Query Store and you didn't adjust the amount of data that it can store. So something to keep in mind.
Got it. Another question from Jeff: how do you turn Query Store off for the entire instance?
So I don't believe you can turn it off at the instance level. So everything that I know about Query Store is that it is a database level configuration. Yeah. And so I am not aware of anything that allows you to turn it off from an instance level, unless you just downgrade it to not 2022 or not 2016, but that's the really cheeky answer.
How do you turn Query Store on off for database after it's turned off for the instance? So again, you said that, and I think I can't remember, you can do it on an instance. So basically, if you can turn it off, you can turn it on, but it's only on the database level.
Correct. So you'll be all of the Query Store configuration you'll be doing at the database level. And so if it's off, you can turn it back on, vice versa. There's really not anything that you're going to be doing at the instance level for Query Store.
And fourth question, is there a way to turn off Query Store for all databases that were enabled at the database level?
I haven't tried it, but I imagine that if you turn it, let's say you're sitting on a 2022 instance, I think that if you disable Query Store on model, that it may perpetuate to any new database that you build on 2022. I've never tried it, and if we have time at the end of the session, we can test that real quick.
I actually have a script for that, but it's basically runs cursor on all databases except system databases. It does alter database, and most of the stuff that you change, basically, it's a dynamic SQL.
Sure. Yeah. I mean, you can run MS for HDB. You can do whatever you need to, but yeah. But I'm trying to think if you can effectively turn it off by default, and that may be a way that you can do it.
You're saying that if you disable that model for any new databases, is going to be turned off.
Maybe that's speculation, but it'd be fun to test if we have time at the end.
Okay. And Jeff saying thank you.
Great. You're welcome. Great questions. So I love getting the questions in the moment. So let's go ahead and push forward. So we're going to start diving into the actual statistics that are popping out here in QueryStore. So the first one that we're going to talk about is runtime stats or runtime statistics. So we're going to go back to our collection interval term that we talked about earlier. And we're going to summarize these metrics over this interval. So by default, it's 1 hour. We change that interval to 1 minute for this demo. Don't do that in production, but by default, it's 1 hour, and typically 1 hour is sufficient for everyone. The thing that is going to be of interest is that these statistics are stored at the plan and interval grain. And so for people that work with data warehouses, they understand the concept of grain and granularity. But for those that don't, essentially what we're saying is that per plan and per interval, we'll have one data point for a runtime statistic. So an execution plan for this particular hour by default, but for this demo will be for this particular minute, we'll only have one piece of data. And as that more data comes in, it will update that piece of information. It will not generate new pieces of information. This is going to give us a ton of aggregated data. We're going to get execution counts, mins, max, averages of durations and operations. We're going to get row counts, degrees of parallelism, et cetera, et cetera. I could go on for days. There's plenty more. There's tons of stuff in there. The DMV that is going to be relevant for this particular one is sys.querystore runtime stats. The great news about a lot of these QueryStore DMVs, most of them, not all of them, but most of them start with sys.query_store_ something else. So if you need to search for them, that's a pretty quick and easy way to try and find what you're looking for. Very similar, we have weight stats. So when you run queries, you have weights, you incur weights, whether you're reading data from a disk or you're waiting for parallelism or whatever it might be. A topic for a long session, but essentially these weights will accumulate when you run queries. These statistics are stored at the plan weight category interval grain. So for a given execution plan, for CPU weights over this particular hour, we'll have one data point, and that data point will get updated as more and more data comes in. Weight category examples that you might see: network I/O, CPU. Those are a couple of quick ones that a lot of people can resonate with. The big thing that I need to call out here is that these are not individual weight types. You will not see a CX packet or a CX consumer or an async network I/O weight type. You will only get the category for that particular weight. So it does get summarized up to the weight category level. So something to keep in mind as you're starting to leverage this data. Again, more aggregated data. We'll take a peek at it here in a second. This particular DMV, I mean, it's very different than the previous one. It says QueryStore weight stats rather than runtime stats, but very straightforward, very easy to find. So our third demo, runtime stats and weight stats. Great news is we kicked off a query that populated some data for us that executed successfully. Wonderful. So what we're going to do, and this isn't going to be overly involved, but we're just going to start walking through each of these DMVs one at a time to start understanding what we're getting out of here. So first, I'm going to pull up this QueryStore runtime stats interval DMV. What is this DMV? So this just looks like dates. Well, because it is. Kind of going to data warehouse theory a little bit, rather than assigning dates and time ranges and putting those big data types on every piece of data that you have, it's much easier to essentially generate these intervals and then assign a single integer to that and then reference that with your other tables. Good relational modeling, yay. Again, for our particular demo here, we are generating intervals over 1 minute. So using this one particular example right here, we see that we have an interval for 324 to 325. By default, this will be 1 hour. So you're not going to see 1 minute intervals. And you'll actually see potentially gaps in intervals if no data was generated. I mean, we can see here that we have a gap in the interval. So things to keep in mind. And you'll see that these intervals only start getting generated as soon as QueryStore is turned on for that particular database. As soon as you turn it off, it'll stop generating these intervals. So This is kind of explains why we don't necessarily want to be turning this down to 1 minute for our production database for the next 5 years. That wouldn't be great. So moving forward here, we have our query store runtime stats. And this is going to be a lot of IDs, a lot of numbers. I'm going to try and focus on some of the really interesting parts here for us. But essentially what we have is that we have runtime stats IDs. This is just going to be the identifier for this particular DMV. But this is where it starts to get interesting here. So we have our plan ID that is referenced in that query store plan table that we used in previous demos. And we'll pull it up here again in a second. But you can see that that plan ID has generated multiple intervals based on its runs. So if it ran over multiple intervals or over multiple 1 minute periods for our demo, we're going to see a second row for that. And that's what's occurring here. So for both plan ID 1, as well as for plan ID 6, it ran for 2 different intervals here. So that's exciting to see. We can see the cardinality and how this all happens here in this DMV. We can see the first and last execution times for that particular data point. And then here's where we're getting all of the metrics that are of interest. So the number of executions, average durations, mins, max, standard deviations, CPU time. I mean, you'll see as I scroll across that there are just tons of data points here that you can leverage as you see fit. I'm not going to dive into each of these. For the most part, all of them are pretty straightforward. So you can dive into them as you see fit, but just know that there are an absolute ton of columns on this particular DMV for runtime stats. You can get great data from that particular DMV. Same thing with the weight stats here. You're going to see something very similar. Our grain is slightly different here. We now have a plan ID, an interval, and a category. So let's hone in on just this one particular plan ID for the moment. So what we can see is that we have those 2 different intervals that we saw on the previous DMV, because that grain showed us that it was starting to show up that we had 2 different intervals where it ran. But for plan ID 1, we have 2 different intervals. But then inside of each of those intervals, we have different weight categories that have incurred some level of weights. So latch weights, network IOs, parallelism, memory, CPU, all of those goodies that we kind of want to see come out of this. Same thing here, a little like much more condensed, but we have wait times, mins, maxes, totals, averages, standard deviation. The reason why we have aggregates here is kind of going back to the fact that we're summarizing this data over the interval. Again, these are not individual executions of that query. This is that particular plan being summarized over a particular period of time, an interval. So something to keep in mind as you start digging through these particular DMVs. That's it here for these particular DMVs on the stats side. Any questions on this?
Joe is asking, how do we truncate or remove all the query store data that we have collected, especially in emergency if it's got too big? Or
Sure.
is that something that is coming up in a presentation?
So we actually already touched on it. So we came onto this here in this early script. So I'll just call it out here. Okay. There is this particular query that will just wipe all of the query store data. This will not turn off query store on its own, but this will clear out all the data that query store is currently consuming.
And turning it off is going to run query store clear as well?
Query store clean. Can you elaborate on that a little bit?
Yes, if you do alter database, I guess queries, I mean, it's not exactly, well, set query store off, I think, right? Or disable. Is it going to clear the query store before it's going to turn it off?
I believe it does clear query store before it turns it off. I'll have to double check on that one, but I believe it does.
Okay.
If you want query store to stop capturing data, but you want to preserve the data that's currently still in there, then what you do is you'd flip, coming back to the configuration option that we ran in the first one, is that, or actually that was in the slide, but essentially you'd be setting the query store, the mode to read only rather than to read write.
Got it. Thank you.
So that's a good way to stop the collection of data, but to preserve what's still there. Any other questions?
No, no more questions.
Great.
Thank you.
So next topic is that there are some great canned reports in Management Studio. These are just kind of some screenshots of what we see, and you actually saw some of these in DB's presentation as well. So we have a set of canned reports that we can interact with directly through Management Studio. And rather than just showing you screenshots of these, I'm just going to dive straight in and start playing around. I want to make sure that we stay prompt on our presentation here. So inside of our database, we have this query store node. And then you'll see that we have these presentations here. We can double click on, say, overall resource consumption. And we can then the time frame is last month. So let's go to the last hour. And now we start actually getting some meaningful data. So because we've really shrank down our interval, it kind of throws it off by default, but we can start hovering over these individual data points and see essentially a GUI version of that data that we looked at inside of these DMVs. So we have execution count, durations, logical reads, CPU time, and then all of that summarized here in a graphical fashion. So it's great to be able to have. We can configure these options. You can saw that I already clicked on these, but you can check these on off, change your time interval, change the time format, all of those that might be relevant to you. I'll pull up another one here. Top resource consuming queries. Of the queries that we ran, we can see that this particular one with the really crappy predicate, total duration in milliseconds, do some math here real quick, divide by the square root of pi, 28 seconds. So that's the total duration of those 3 executions that ran. So if we just do our quick math, roughly 9 seconds per execution. But what is also interesting is that it did generate another plan. See that plan count of 2. So just calling that out here real quick. And then how we see that represented over here, and again, this is something that Deepthi's presentation talked about, is that we see that we have 2 different colored dots here. So we have plan ID 1, plan ID 3. We can click on these individual dots here to get a little bit more information about that plan itself. So you can see that it is now populating that execution plan down here in the bottom window. So kind of cool stuff that we have just through the UI in Management Studio. Moving ahead here, we're going to start getting into a little bit more, I don't want to say advanced, but let's say intermediate query store. So one of the interesting topics for this that people might use is what we call plan forcing. And so I like to call this section, so you think you're smarter than the optimizer. And you just might be at this point in time with the data the way that it is now and the system configured how it is. But things to consider is that it is very similar to query hints and plan guides. You want to use them very sparingly. They're great as a band-aid, but they always need to be revisited. So if you think you're smarter than the optimizer and you force this plan and then suddenly 4 vCPUs get pulled away from that machine, or 12 vCPUs get added to it, or it gets doubled in memory, or half the data in the tables that are involved get removed from that table, or indexes get dropped. That might be something that will now set you up for failure with your query. So plan forcing is great in very targeted instances. Something to keep in mind that it is there. It essentially says that when this particular query runs, I want it to always use this particular execution plan, regardless of what the system's configuration is and how it's changed since I forced it. So without further ado, we'll jump into the demo. Start having some fun here because we all like SQL, right? Our last demo for the evening is going to be to force our query plan. So let's take a look at the state of our DMVs that we had. So this is based on all those queries that we ran to populate some of the runtime and wait stats. So we have our plans, we have our queries, we have our query text. Good reminder in my comments. So we're going to come back to our original query that we ran. So this %s, it's back again, that self cross join. And we're going to run that query. We're also going to take a look at the actual execution plan real quick. And I hope that a year later that this still holds weight, but essentially what we see here in this execution plan, I'm not going to dive into really all the nuances of this execution plan, and I don't need that tooltip to show up for this. But the important part that I do want to call out is that we have parallelism. So this query went parallel because of that %s, that leading wildcard. Not a great way to query data, but it is going parallel. So what happens if I just delete all of the data from that table? Let's go ahead and see what happens. Boom, all the data is gone. Well, let's run this query one more time. I would sure hope that it's not going to go parallel because there's no data in there. Let's run it. Let's take a look at our execution plan. It did not go parallel. So that's great. We don't want it to go parallel when there are no rows to read. Fantastic. Now, how can we start getting a little bit diabolical? Well, let's go ahead and force a plan, because why not? So we have this data in here, and the area that I do want to call out is based on this query ID of 6 right here. So essentially, this plan ID of 1 was our parallel plan. This plan ID of 7 was our not parallel plan. So reminding you of the state of the table right now, the table has no data in it. We just ran that query and it did not go parallel. Well, let's say that we just want to have some fun and maybe we want it to always go parallel. We would never do this because that's just poor practice, but we'll run this DMV again. And what we're going to do is I'm going to slim down just a tiny bit on the number of columns in this plan DMV, but I'm going to call out this is forced plan column here. So that bit is now 1. That says that when I run that particular query text, that query ID, that select cross join %s, that it is going to run that plan ID that's in there, plan ID of 1, which was going parallel. We still have our actual execution plan on. We're going to run, again, that exact same query. And we're going to show and demonstrate that we made a query that's against a table that has 0 rows go parallel. So applause, yay, I'll take a bow, I'll be here all night. Actually, now it's late. I'm not going to be here all night. But yes, we did actually show that we can force a plan, that we can force a really bad plan if we really want, and that the state of data changing can severely impact forcing plans. So please, 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 if you decide to use forced plans, to make sure that you revisit them and also understanding what you're doing with them when you utilize them. So that's the fun of forced plans. I do have in this slide deck some additional topics that would just require a lot more time than we have in this 1 hour period, but you have things called plan feedback. So essentially, as queries run, it's going to communicate with query store of, hey, I ran faster, slower, up, down, left, right, and this kind of touches on what Deepthi talked about a little bit earlier. We also have query hints and query hint feedback that gets stored inside of query store as well. A great thing to really start poking around with. Secondary replicas. So you can actually get the query store data from a secondary replica stored in query store. And so you'll see a replica ID column in a lot of the DMVs, and that's what that means. is that if you're running, say, read-only workloads against your secondary replicas, you're going to generate query store data for that, and you'll be able to utilize that as you see fit. Also, how in-memory OLTP interacts with query stores. So a lot of good reading here. These are all links. Again, if you would like the slide deck, if you would like these scripts, please feel free to reach out to me on LinkedIn. I'm happy to send them over to you. Play around with them as much as you'd like. If you have any more follow-up questions, now is a great time for that, but I'm also available afterwards and moving forward as needed.
Brandon, do you have public-facing GitHub repo or maybe your own blog that you host the presentation?
I actually do not. So I'm happy to send them over right now. That might be something in the near future here over the summer, now that I have a little bit more time available to me. So definitely keep your eyes out for that. And if that is something that is interesting to you, please connect with me on LinkedIn. And then if and when that does come to fruition, I'm happy to pass along that information to you. Any other questions?
I'm going to be reaching out to you. We have a user group public repo, GitHub repo, so I can post it there.
Perfect. That sounds
in
great.
general, it's a good idea to have basically to control your content.
Sure, absolutely. I fully agree.
Well, did you also cover that in Enterprise Edition you can enable auto tuning?
I did not. So this was just kind of super low level, and DeepThea already touched on that. So hopefully that sunk in well to everyone.
Got it. I'm gonna read comments. Jeff, thank you for great presentation. Pusha, thank you for the informative presentation. I see Ron is typing something.
The three dots.
Thank you both for great presentation.
Wonderful. Well, thank you all so much. Thank you for taking time out of your busy days. Thank you for staying up late for some of you. Steve, thank you so much for the opportunity. DeepThea, wonderful presentation beforehand. Please feel free to reach out. But thank you all, and I hope you guys learned at least one thing today, and hopefully a little bit more than that. So really appreciate it.